I have been asked countless times, how do you get better results than AI-based collaborative filtering or content filtering without intruding on private data? This video is intended to explain how decision intelligence or human-like intelligence yields superior results. Human-like intelligence works by mimicking the brain, which is by assessing the needs. And these are expressed as trade-offs between the decision criteria. Trade-offs, by definition, are a balance between two desirable but incongruent characteristics, a compromise. For example, for a laptop, both a large screen and lightweight are appealing. However, the larger the screen size, the heavier the laptop. The only way to mitigate the conflict is to trade off between screen size and weight. Thomas Sowell, a prominent American economist, said, "There are no solutions, there are only trade-offs." Let's start by comparing decision intelligence with content filtering, also known as faceted search or parametric elimination. Given a set of cars, each has a price and a performance. Content filtering is equivalent conceptually to drawing a box price between $18,000 and $22,000, and performance between 200 and 300 horsepower. Note that it requires a good understanding of the domain. You select all the results that meet your criteria, in other words, the ones that are inside the box. However, criteria are not random. They have a behavior, an order, a direction of preference. For example, everything else being the same, a 300 HP car is better than 290, which is better than 250. This is bad news for content filtering, SQL, and other parametric elimination techniques. This means that there is an ideal result. This ideal is often hypothetical. Pareto optimization teaches that it is at a corner of the box. And thus older techniques miss all the results that are close to the ideal, but just outside the box, despite being significantly more compelling. Human-like intelligence measures the distance of every element to the ideal, and thus provides for each vehicle a score reflecting its distance to the ideal. Now, with human-like intelligence, you no longer miss pertinent results, and often the best results. Most importantly, human-like intelligence introduces the concept of trade-offs expressed as the relative importance of a given criterion. By stretching the price axis, we are saying that price is more important than performance. As you noticed, by stretching the price axis or giving more importance to price, the elements that are closer to the ideal change, and thus the results are a lot more pertinent as they take into account the relative importance of the criteria. Imagine the same problem in multi-dimensions. This is the power of human-like intelligence. Now that we can teach computers to think the way humans make decisions using trade-offs, we can solve problems we couldn't fathom before. In summary, we have just demonstrated the superiority of human-like intelligence. It simply yields better and more relevant results. And while with content filtering you need to have a good understanding of the domain and the data set to avoid over-constraint or under-constraints, human-like intelligence provides a ranking or prioritization of the results based on the trade-offs and expert knowledge at scale. Now let's change gears and compare human-like intelligence with artificial intelligence. First, let's compare the metaphors. AI mimics neurons while human-like intelligence mimics the way humans make decisions. Which one do you think is more effective? AI is a glorified statistical classification engine. Human-like intelligence makes decisions using trade-offs. An AI-based recommendation engine will first identify a cluster of similars. To be effective, the larger the data volume, the better trained the system is. And this is all about private data. In the case of someone purchasing a pizza and a salad, all types of information can be used for their hobbies, to how often they refuel their car, to the temperature of their house, to their court brand. Then behavior of the closest neighbors is analyzed to identify patterns based on which a beverage is recommended with the pizza and salad. The dependency on invasive and private data in large volume to keep learning brings the ethical issue to the table. As a result, AI/ML is marred with three challenges. It cannot work with little to no data. It has no logic incorporated. The data is the code. It also requires uniform quality data. As a result, AI is not good for decisions with uncertainty. It is not trivial to set up and constantly monitor and adjust a system for its shift. AI is a black box and has challenges with causality. In other words, it cannot explain why. And finally, there is no way to instruct an AI/ML system to set goals and objectives. This is a foreign concept to AI/ML. Yet human-like intelligence is based on setting dynamic goals and objectives. To solve these problems, we have architected the human-like intelligence platform on 3 core pillars. First, criteria. Selecting the criteria for each use case is done using expert knowledge. Generative AI delivers expert knowledge at scale. Second, it is important to understand the way we think about each criteria. Capturing the criteria behavior using traditional AI and applied typically to publicly available data, such as the specifications of the products for a recommendation engine. Thirdly, we introduce the concept of trade-offs, which can be explicitly expressed by the users. They may be programmed or calculated, or they can be inferred. The inference engine uses the reverse propagation model to reverse engineer a query, and from a ranked subset of results, it can derive the trade-offs. This technology is unheard of and opens up a slew of opportunities. To illustrate the point, let's take the selection of Nike soccer cleats in e-commerce. Traditionally, you can pick a color, say blue. You can also pick another, pink. But there is no way to express a natural need such as, I love the blue, but I will take the pink if it is $50 cheaper, without trade-offs. One of the key questions to differentiate the cleats is the technology, and the choices are Flyknit, Lunarlon, Flyease, etc. Terms that not a single player out of 100 surveyed could explain what they meant. Instead, expert knowledge via generative AI teaches us to match the cleat to the playing style of an athlete. As a result, a player is asked about his speed, dribble, shot, and precision. Then you balance the style with price, color, and other decision criteria. It seems a lot more powerful to match a player with a cleat that fits her individual playing style. You could not do that with content or collaborative filtering. These business objectives can be adjusted dynamically with the human-like intelligence platform. This cannot be achieved with any other solution.